So in this video and the rest of the videos in this module, we're going to explore various aesthetic approaches to algorithmic composition. And we'll look at some simple examples that we can code with Python, EarSketch, and Reaper. And we'll look at some important historical examples of these approaches in practice. So I want to start this exploration with chance music. So we'll look at making random decisions and how to do it in Python and in EarSketch. We'll code up a simple example, and we'll also look at some historical context, particularly the work of John Cage. So why would musicians want to make random decisions as part of their algorithms? Why would they want to give up that level of control? There's a few different reasons why. One is goes back to this notion of 20th century American composer John Cage to let the sounds be themselves, to try to distance the composer's role somewhat from the process of making decisions, and to let chance take over to make some of those decisions so that structures might emerge on their own rather than being dictated by the composer. One classic example of this, one of Cage's most famous pieces is called 4 minutes and 33 seconds. And in a typical performance of the piece, a pianist sits down at the piano and sits there for 4 minutes and 33 seconds without playing anything. But it's by no means a silent piece. There's a lot of sound happening in the piece. It's just not sound that the pianist is actually creating. It's all the ambient incidental sounds that are happening in the performance space. It might be a truck driving by, or the air conditioning humming, or people rustling their programs, or laughing nervously, or whatever it might be. Those sounds become what the piece is about and kind of what it is framing. And so there's no structure to that or algorithm to that the Cage is kind of imposing on it. He's letting those sounds kind of be themselves and letting listeners decide for themselves how to think about them musically and put them together to make meaning out of them. So central to this notion of chance is this question about the differing roles of the composer, performer, and listener in realizing and experiencing a piece of music, and where the structure and the meaning for that music comes from, and the different roles that people play. Chance can be a way to take some of that role of creating meaning in a work and creating structure in a work away from a composer and challenge these other entities, the performers and listeners, to play a greater role in discovering it for themselves. Chance can also be a means to an end. It can serve a much more pragmatic purpose of not serving some broad aesthetic, but simply trying to create a particular musical texture or type of sound that might be easier to create through a bunch of random decisions than through a bunch of intentional decisions. And we'll explore that idea even more in the next video when we turn to stochastic composition. But right now I want to talk about how randomness works in Python and EarSketch. EarSketch has one function to support making random decisions. It's called select random file. And you pass it a folder, and I'll show you how to find those in a second. And then it will randomly select a sound file within that folder each time you call it. Python has a ton of different random functions that are part of it. In fact, it has its own a special API just for randomness. So if you want to use these functions, you have to say from random import star, the same way you say from EarSketch import star at the top of your script. Two of the ones that I want to focus on right now are a rand int, which will pick a random number between a low and high integer that you give it. So if you pass in 5 and 8, then it will randomly return either 5, 6, 7, or 8. And then random returns a random number between 0 and 1. And that's inclusive of 0, so it might, 0 is a possible number it will return. It is exclusive of 1, so it will never actually return 1. It can return 0.999999999, but it will never actually return 1. So now let's look at how we use those random functions in the context of a real script to apply some chance procedures to composition. So right here we have a simple script, a random file placer. And so at the top we have our regular EarSketch import statement to bring in the EarSketch API. I have a second one as well to bring in all the random functionality. This is actually an API that's part of Python, but you have to explicitly tell Python you want to bring it in if you want to use it. So we have from random import star as well. Then I have my usual init and set tempo, And then I'm defining a sound folder. And this is a folder I'm going to randomly start pulling sound files from. So let me show you how to do that really quickly. Go over to EarSketch here, and it's pretty straightforward. Each of these folder names that you see in the sound browser is actually a constant. So if I go to Richard Devine, dubstep, dub drum, I can simply copy and paste that entire folder name, and that represents a folder of sounds. And so if I use select random file with that, then I am randomly picking from all of these drum loops that are inside of this dub drum folder. There's no handy paste button there because we didn't want you to potentially get confused and try to paste a folder in where you actually need a sound constant as opposed to a folder constant. But it's easy enough to select those and copy and paste them. So let's come back to our slide here. So what I'm doing in this line is I'm assigning the folder constant dub drum to the variable sound folder. And then I have a for loop here. And so this is going for measure in range 1 through 9. So measure is going to take on a bunch of different values in this for loop. It's going to be 1, 2, 3, 4, 5, 6, 7, and 8. So each time we go through, these 2 lines of code are executed with measure taking on successively each of those values. So the first thing I do is each time I pick a different file, and this is an EarSketch API random function, select random file, that takes in my sound folder and returns a random sound constant from to represent one of the sounds from inside of that folder. So each time that's run, it's going to randomly select a new a sound file from the folder. And then I just use fit media to take that sound, put it on track 1 at whatever my measure is. So each time I'm putting this in a new measure, and I want it to last 1 measure each time I put it in. So I take whatever measure I started it at, and I say I want it to end at that measure plus 1. So 1 measure later. And then I just call finish, and I'm done. So let's go ahead, and we'll go into we'll go into our web browser here, and I've got the exact same script here, so I can go ahead and run it, and we can see what it does. So you can see every measure, we have a new sound file starting. Okay, so that was kind of random. I'm randomly picking a bunch of sound files, playing them one after another, and I could see how I might make an interesting kind of a randomized drum beat that way. But what if I want something even more random? What are some other things that I can randomize here? Well, the first thing I might be able to do is randomize my tempo. So every time I run this, I get a different tempo. So I'll do rand int here and pick a tempo between 120 and 168, let's say. And then what are some other things I can randomize? I can randomize where these sounds are being placed. So instead of always putting them on a successive measure, I can have them go at some random starting point and random ending point. So if I want to do that, I'm going to change this measure index, loop index, to something else. I'm just going to call it I for index, because it's not going to represent measure numbers anymore since I'm randomizing these starting points. And I'm going to run this a lot more. I want more random here, so I'm going to go up to, say, 30. And so each time I'm still going to pick a random sound to use. Then I'm going to pick a random start time. So I'm going to do a random number. So random gives me a random number between 0 and 1. If I multiply that by say 8, I'll end up with a random number between 0 and 8. So then I'm going to randomize my ending time too as to be start plus random. So it'll be, since random gives me a number between 0 and 1, my ending time will be somewhere between 0 and 1 measures after my starting time. Then I come down to my fit media call, and I'm still referencing sound. I'm going to do my starting measure as start and my ending measure as end. One more problem here. If I do all of this stuff on track 1, a lot of my sounds are going to start overlapping with each other. And in a DAW, that's not usually allowed. We can only have one sound on one track at the same time. So I'm going to go ahead and just randomize the track that this goes on, say between 1 and 10, so that that's less likely to happen. It'll still probably happen a little bit, but I'll minimize the amount that it happens. And I'll go ahead and run my script. And I have a bad input here on line 11, a little parser that's coming back. I think that I did some tabs someplace instead of spaces, or spaces instead of tabs. So I can go ahead and I can fix that, see if that one's okay. Yeah, this one also seems like it's not right. So let's try that again. Hopefully that'll work now. Yeah, that seems to have worked now. So we can go over to our workstation. And you can see how they're all kind of randomly spread around different places. So that sounds a lot more random than the first example that I did. I did want to take a moment and talk about a historical example that this example was really inspired by, a piece, again, by John Cage called William's Mix that he wrote right around the same time as 4 minutes and 33 seconds. This was done not with computers, but with analog tape splicing techniques, reel-to-reel tape decks, like the ones that we looked at in Module 2. So he had 8 different tracks of magnetic tape that he was working with. And he had 600 sound recordings that he had recorded, and he grouped them into 5 different categories. And then he used chance operations, and this was done by hand, not by random functions on the computer. So he was actually rolling dice according to, as structured by this, or kind of inspired by this ancient Chinese I Ching. And he was using these dice rolls and kind of the results that came as indicated by the I Ching to make decisions about what sounds or what sound categories to place on these different tracks at different time points, how long they should be, how they should be spliced together, parameters like this. So he did this all by hand, rolling all these dice, and he ended up with a 192-page score. It's a graphical score that shows kind of the envelopes and some textual information about what should be included on each of those 8 tracks in different places. It took him 1 year to put this whole piece together, working with a number of people helping him to do all of these tape splices as indicated by that 192-page score. And the result is not so different from the example that we just coded up in EarSketch. We have a bunch of kind of things that are placed by these chance operations at different places on this 8-track, in that case, this 8-track a kind of multi-track timeline, but again done with 8 magnetic tapes in this case. So what we've covered in this video are reasons for approaching music from a chance music perspective, some Python and EarSketch functions that enable us to do that, and we've talked in particular about the work of John Cage. But what we'll be moving towards in the next video is continuing to explore making random decisions, but controlling them in some very careful ways to create particular distributions and mappings so that we can create music very intentionally and keep a lot more control over the music, even though we're using randomness.